Hello everybody, we are just getting ready to start chapter 24, organic compounds. Your organic compounds are compounds that contain carbon and mainly found in living organisms, just like I have written here. The bonding that takes place with carbon, because they have 4 valence electrons, in other words 4 electrons in their outermost energy level, they typically form 4 covalent bonds. Now these bonds can either be single, double, or triple. They can be chained, branched, or ring structures. And rest assured, I will show you examples of your single, double, or triple, chain, branched, or ring structures very soon. We will go over examples of each, okay? But I want to talk a little bit about hydrocarbons in particular. They're carbons that have just carbon and hydrogen. We've talked about that in this last chapter. Again, hydrocarbons have just your strictly carbon and hydrogen. Here are some examples of each. I want you to note the highlighted prefixes on each of these. You can see that I have meth, eth, prop, bute, pent, hexa, hepta, and octa all highlighted. Those prefixes are telling you how many carbons are in each of these. As you can see, meth, get my pen going here again. Again with a silly pen, right? Has 1 carbon. Eth has 2, prop has 3, bute has 4, pent has 5, hex has 6, hept has 7, oct has 8. So in other words, meth has 1 carbon, eth 2, 3, 4, 5, 6, 7, and 8. Anytime you see those prefixes, you know that that's exactly what that means. Again, meth, eth, prop, bute, pent, hex, hepta, octa. You just simply have to memorize those. But meth will always mean 1 carbon, eth will always mean 2 carbons, prop will always mean 3 carbons, bute will always mean 4 carbons, penta will always mean 5 carbons, hexa will always mean 6 carbons, hepta will always mean 7 carbons, and octa will always mean 8 carbons. The ending also means something, the ane. A-N-E. Ane is actually telling you that they are all single bonded. Now, if it ended in ene, this would mean a double bond. And ine means a triple bond. So there are 3 endings that you're going to experience. Ane, ene, ine. Again, ane, which is what we have here, are all single bonds. Ene, double, and yne, you'll hear me say it as ine, would mean a triple bond. Let's strictly go over these single bonds first, okay? Again, all of these have single bonds because they end in ane. Methane, so let's try and draw some of these structures. Again, carbon, which we've talked about before, has 4 valence electrons, 4 electrons in its outermost energy level. Now, when we did electron dot, we would typically write it like this. That's telling you, again, it has 4 electrons in the outermost energy level. Now, keep in mind, these atoms tend to move, rotate, so these electrons do shift. Okay, so I'm going to erase this. I thought I was going to erase this. There we go. Put my pen back. Here is carbon. So if I have 4 electrons in the outermost energy of carbon, carbon has the capability of forming 4 covalent bonds. Because these are carbon and hydrogen, I'm going to attach hydrogen on all of these sides. That is methane. 1 carbon, meth, ane, meaning sharing a single bond there. And that's what we have going on there. You have 1 carbon sharing 1 pair of electrons. Carbon here sharing, and this is considered a pair of electrons in single bonding. So you have 1 pair of electrons that is being shared there. Remember, hydrogen is full and content with 2 when it's full. Okay, it has one in its outermost energy level, but now because it's sharing these electrons, it now has two, and that's when it's very content and happy and completely stable. Carbon, remember, these elements need 8 in its outermost energy level to be its most stable. Well, sharing all 4 of these hydrogens, it is now stable. We have 2, 4, 6, and 8 surrounded with carbon because they are sharing these electrons in all of these areas. This is, again, methane. To draw ethane, eth means 2 carbons, right? So I'm just going to immediately draw my 2 carbons. Ane is telling me a single bond, so I'm just going to write a single bond here. On this one, you will also see it like this. I just wanted to draw out the electrons to make it a little more clear. This is your single bond here, attached to 4 of your hydrogens. You can see in the formula right here, going back to methane, we have 1 carbon, that's what this is telling you here, 4 hydrogen. That is what you're drawing right here. With ethane, you can see in the formula, I have 2 carbons. I do have 6 hydrogens. With ethane again, 2 carbons, so I would definitely first put my 2 carbons down. I would give it a single bond. Because it ends in A-N-E, I do know it has a single bond going on there. I know carbon needs 4, has 4 electrons in its outermost energy level. It needs to share these bonds with hydrogen. We're just strictly talking about hydrocarbons here, so carbon and hydrogen. And I would just so very quickly add my hydrogens there. This is where I get my 6 hydrogens all around carbon, all sharing 1 pair of electrons, sharing them with hydrogen. So these guys now, if we count what carbon has, here's carbon. I now have 1, 2, 3, 4, 5, 6, 7, 8, because again, they're sharing. This carbon here, 1, 2, 3, 4, 5, 6, 7, 8, sharing. Very stable, very nice. Ethane, okay? These compounds again are just carbon and hydrogen. So propane, you're probably getting the hang of this. You can see propane, I'm going to draw it a little smaller over here in this corner, has 3 carbons. 1, 2, 3. I can see the 3 here, but even if I didn't have that formula there, I know by this prefix telling me prop means 3 carbons. I know by the ending ane, they're going to be attached by single bonds, the carbons. Okay? So that would be the first thing you would draw when drawing these structures. Okay? For now, I'm giving you the name and the formula, and we're working on the structures as you can see. So with this, it's telling you there's 8 hydrogen. But even if I wasn't given that formula, I would be able to figure that out because I've got my 3 carbon here, I've got my single bonds. Now what does this carbon need here on the end in order to become stable? I know I can attach 3 hydrogens. What about this carbon? I've already got 2 right here. It's sharing a pair of electrons with this carbon. It's sharing a pair of electrons with this carbon. I only have room for 2 hydrogens. Now it has 8. 1, 2, 3, 4, 5, 6, 7, and 8 to be completely happy. On this last carbon, again, it's only sharing 1 pair of electrons here. I have room to attach 3 more. A little confusing maybe now, but it will become clear, I promise. Okay? That is propane. So I have methane with 1 carbon, ethane with 2 carbons, propane with 3 carbons. Let me go ahead and erase this. Hold on. And I'll go ahead and draw a couple more. I want to stay on this page. Okay, butane, 4 carbons. So the first thing we do is I know there's 4 carbons, even again if I wasn't given that formula. So I'm going to just put my 4 carbons down. 1, 2, 3, and 4. Ends in A and E. So I'm going to attach a single bond between all of those. I know I can have, it has 4 electrons in its outermost energy level. So I'm going to make sure to attach 3 to this carbon on the end here. Just start right here, because I already have 1 right here. I can attach 3 more to make 4, excuse me. And then I'll attach my hydrogen, giving me 4 pairs of electrons, giving me 8 electrons total, making it very stable. This carbon already has 1, 2 attached to it. How many can it hold? 4. Let's attach 2 more and slap my hydrogens on. This carbon, how many are already attached to it? 1, 2. How many can it hold? 4, right? Altogether? So how many can I add? 2 to make 4. As in 4 pairs of electrons. What about this guy? He has only 1 attached here, right? So there's room to add how many to make 4? 3. I can add 3 more pairs of electrons that it can share. This is now very stable. In how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's exactly what it says here. And I have 1, 2, 3, 4 carbons, and that's exactly what it says there. Okay? Should we try another one? Let's try pentane. I'll erase this one. Pentane, 5 carbons, 1, 2, 3, 4, 5. It ends in A and E. Single bond, 1, 2, 3, 4. I'm not really counting those. I'm just attaching them because I know it ends in A and E. I know I have 5 carbons. That would be the very first thing you would do on each of these. Okay? So now, even again, if I wasn't given this formula, I know how many hydrogens I can attach to each of these. Let me start on the right here again. I only have 1 right here. I can add 3 more to make 4, so I'm going to do that. Carbon has 4 electrons in its outermost energy level. How about this carbon? It already has 2 pairs that it's sharing. I have room to add how many more? 2 to make 4. You want it to always have 4 pairs of electrons attached to it, sharing, bonding. This carbon, take a look at it. How many is it sharing? 1, 2. I need 4, so I can add 2 more. This carbon, how many does it have? 1, 2. I need 4, so I can add 2 more. And this carbon, how many does it have attached to it? Only 1. So if I need 4, I can add 3. Okay? How many hydrogens do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what it says right here, 12 hydrogen. How many carbon? 1, 2, 3, 4, 5. 5 carbon. So let's say I gave you this structure and I asked you to give me the formula. All you would have to do is count the carbons. 5 carbons, 12 hydrogen. I now have the formula C5H12. To figure out the name, I would count the carbons. 1, 2, 3, 4, 5 carbons. I know the prefix for 5 carbons is penta, so I would write penta down like I have here. All single bonds, I would add an A-N-E, so pentane. That's where that all comes from. Okay, let's do hexane. Hex means 6, so I'm going to add 6 carbons. 1, 2, 3, 4, 5, 6. It ends in A-N-E, so I'm going to attach my single bonds because A-N-E means single. Ein, 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 single, double, triple.